Okay, this week's video covers the second part of the first chapter, which is BJP section 1.4 to 1.5. And the primary topics that we will go over are very fundamental software engineering design topics. And these are good and best practices that you will need to stay throughout CSC15 and beyond. So it is definitely worth your while to invest time and effort into learning these practices and these basic frameworks for programming. So the two main ideas in this video are that of decomposition and good software design, and these are interrelated. So when we look at a problem in the real world that we wish to solve using a computer and using a programming language, then our task is, how can I break this problem down, this big problem, down into smaller parts? And how can I make sure that those small parts are all working correctly so that then I can put together all of these small pieces and assemble the final solution? So towards that, we are going to be talking a lot about methods. We talked about in the first video about how everything in Java gets put inside a class, right? Now, inside a class is our solution. And the main method, or the main method here, is the top level task that needs to be accomplished. And then what we will see is that the main method is the engine that gets the program going. Now, so inside a class, what we can expect to see is the main method, and inside the method, we can expect to see more methods. So I'm going to say method 1, method 2, and so on. So as you can see, we are already building a kind of hierarchical structure where the big task is going to call smaller tasks to solve the problem. And so it is fair to say that methods are building blocks, and each of these building blocks is a task that each of these building blocks accomplishes a certain task. Now, if you wanted to just quickly delve in, we will see that a method consists of multiple statements, and the statement that we've been working on so far has been the print line statement. And so for now, the only thing that our methods can do is contain print line statements. And we will see that we can actually draw and do some powerful things even with a single output statement like the print line statement. But this is how the structure is going to be. And therefore, the building block is the method. The method contains print line statements or statements, and we can call methods. So this is a method called, we can call these methods to perform the task one after the other, to perform the tasks for us, which are the solution to the problem. So methods, therefore, can be seen as a basic unit of our decomposition. So we have decomposed the big problem into smaller problems, or broken up into smaller units. And these are called methods, and these are the units of decomposition. Now I'd like, for us, when we go over the example, we will see that we can define our method once. So once we know this is task A, or this is method 1, and this is what method 1 is supposed to do, once we have that squared away and saved, then what we can do is use the method or call the method to do that particular task, right? So we will, when we go over the example, you will see how exactly we define the method, what is the difference between a method definition and a method call. Method definition is related to structure, creating structure in the program, and calling a method or method calling is related to the flow of execution of the program. So here, as you can see, I've got my method 1, I've got my method 2, and this is the way the execution is going to flow. First, the top level main method gets called. The main method calls method 1, and then it calls method 2, and then it may call other methods. So in sequence, in programming languages, usually it's the sequence of execution. It goes top down. So this is the first statement, this is the second statement, and so on, right? And of course, these methods, Java doesn't know what method 1 is until we have defined it. So somewhere here we are going to say, this is when you call method 1, this is what method 1 is supposed to do. And here is where all your print line statements are going to be. And this is called as the method definition, which is saved in one place and one time only, but it can be called many times. So I can actually, once I define the method, I can say method 1, method 2, call method 1 again, right? All right. So this is the sequence of execution. This is the method definition. This is the method call. So here's the definition. This is the method call. And here is going to be, now we have simply created a main method and we've got a structure here. And the structure consists of method 1 and method 2. We will take an example that will be a little clearer. So this is the structure of our program so far. What is the execution? What is the flow of execution? Now I've got method 1, method 2, and method 1. And here I'm going to say this is my flow of execution. This is my main method. You notice the indentation. Method 2 and method 1 again. So this is the top level. I'm going to say level 0. This is level 1. And at level 1, I've got a sequence of methods. You can also have a method calling another method, in which case we can insert some more stuff here. If method 1 calls other methods, which is perfectly possible, because every task can consist of subtasks. So tasks can consist of subtasks, which consist of subtasks. Right? And just like baking a cake example, baking a cake is a top level task. It consists of making the batter is the first task, right? And then putting it into the oven is the second task. But making the batter consists of subtasks in which you add flour, you add milk and sugar and so on and so forth. So tasks can contain subtasks. And so this is roughly what we propose to cover in the example. And good software engineering design consists of doing decomposition, i.e. breaking down a problem into smaller parts and using these good principles of elimination of redundancy and iterative enhancement, right? What do we mean by iterative enhancement? What we mean is take a small part, make sure that works properly, and before you jump around trying to do the big problem. So our task would be, let's take method 1, let's write this method and see if it's actually test it out to see if it's working correctly. Then write method 2. Make sure it's working correctly before we assemble everything together and before we assemble everything together, so we know that the parts are working correctly. So when we put it together, it's easier for us to test if the complete program is working correctly. We will talk a little bit about elimination of redundancy when we do the example. So let's now move on to a picture. So let's say the problem that we're trying to solve is we would like to draw this picture. Now, this is the big problem. We have to draw this picture. Now let's start with one way of doing this and let's improve our method so we get to the point where we want to be. So here is my way of solving this problem. I have looked at the picture and I have seen that the top part of the picture consists of, let's go back to the picture for a minute. If I look at the picture, it looks like it's got multiple lines, right? And the first line consists of 5 stars, some spaces, followed by 5 stars, followed by some spaces. Second one has 9 stars and then spaces before and after. This one is 15 stars. And then followed by 15 stars, followed by 9 stars, followed by 5, and then it looks like 15 and 9 and 5 and 5 and 9 and 15. So I'm kind of thinking, oh, I get it. I just need to have one single output statement that draws stars. And when I do that, this is what I get. All right. So here's our initial solution. And we are just going to check if it has drawn it correctly. So let's look at the output. And we see that the output is exactly what we were looking for. But when we peek into a solution, we find that the software engineering practices that we're looking for do not seem to be visible. So, for example, we have taken this big task of drawing this picture and just put it down as a series of statements. Now, in this simple program, it may look that, oh, this works really well. But if you have large programs with hundreds of lines of code, then putting hundreds of lines of code in one go are, number one, going to make it difficult to program. Number two, make it hard to debug. Number three, make it very hard to make changes and upgrades. So what we're going to say is, let me see if I can get a pattern in this. And I notice that there is a top part and a bottom part. So this picture, I can break it down into two parts. So 2 units, decomposed into 2 units. So let's say I would like to put this into one method and this second part of the picture into another method. So I'm going to define, already have some methods so I'm going to say public. As you can see, this curly brackets is the beginning of my main program and this is the end of my main program. But this is not the end of my class. So after these curly brackets is where I will define it and say public static void top part. And this is the method definition. Bottom part. And here is where I'm going to now fill in all of those statements here and put them right here. So this is my top part here, and this is my bottom part. And now that I've defined my program, this is the method, define my methods. Define method 1. And then this is my define method 2, and I can do the documentation and say to draw the top part of the picture, and also here I will say method 2 to draw the bottom part of the picture. Right? And now I don't need these lines anymore. What I'm going to do here is I'm going to do the method call. So here is the definition, and here are the method calls. Call methods to draw picture. And I'm going to say top part, and it will draw the top part, and bottom part. And this one is going to draw the bottom part. So let me check that I've done everything correctly. No compile time errors. And I would like to show you that it has drawn the picture as we wanted. Now I'd like to take a little more of a peep into this and find that I have 2 methods, which means my structure chart now is going to look like this. I've got a main program and I've got top part and I've got a bottom part. So here's my structure. And with regard to my execution chart, what I have now here is I have my main program, main method, which calls top part, and I'm going to leave some space and say, and then it calls bottom part. So this is my execution chart. And now I'm going to go back into my JGrasp and see that the flow of execution is that main program gets called first, which calls top part, and top part jumps into this inside. When the program is running, this is what happens. It's a snapshot of what happens. Top part jumps into into this area, and then all of these statements are executed. When this is done, top part is done, it goes back to the main level and bottom part gets called, and then that jumps into this area of code, and then all of this gets executed, and then control is passed back to here. So this is how in your textbook also you will see the picture. Now once this is done, I look and I have done procedural decomposition. My question is, have I decomposed this enough? Do I have redundancy? I have some structure, but do I have the complete structure? Now when I look here, I find that some lines of code seem to be repeated. I've got print line 5 stars, 9 stars, 15 stars. And then here again, I have 5 stars, 9 stars, 15 stars. The bottom part of this thing seems to be 9 stars, 15 stars, 9 stars, and 5 stars, and 15 stars, 9 stars, and 5 stars. So when we look at this, we find that there seems to be a further breaking that we can do into smaller units, and that occurs here. So what I see here is the top unit is getting repeated inside here. So there is a code redundancy or code repetition. This part is getting repeated here, and this part is getting repeated here. So I'm now going to create one additional level and say define method 3 that draws the top hat. I'm going to call it top hat, and I'm going to define method 4 that draws the bottom hat. Top hat and bottom hat. And now I will call this method public static void top hat, and the next one is going to be called bottom hat. It's going to be called public static void bottom hat. And here I'm going to go ahead and move the top hat stuff out of the way into here, and move the bottom half into here. And now I see that I do not need, I'm having a repetition. This code is repeated here, and this code is repeated here. So I don't need to do that. I'm going to take all of this out, and I'm going to put a method call, which is going to be top hat, call top hat, call bottom hat. And here I'm going to say, call the bottom hat first and then call the top hat. So instead of having all of these lines of code here, I'm just going to have, right? So now if I run this program, it should, first let me check that if I've done everything correctly. And then when I run the program, I'm still getting the same picture. Know that at the front end, the picture is looking the same, but the back end is undergoing a lot of changes. So let's go back to our PowerPoint slide and go here. And now you will see that my top part consisted of top hat and bottom hat. This is the structure. And in the structure diagram, I can actually put top hat and bottom hat here. And know that when this is just the structure chart is unordered. We can put the methods in any order as long as they're there, and they show us that the top part consists of these two units, bottom part consists of top hat and bottom part. The order is what is going to be determined by the flow of control, which is the execution chart. And here is where I need to worry about the order. And I'm going to say this calls top hat first, and then it calls bottom hat. And then here, this one calls bottom hat. And now this is going to be top hat. So know that this is the difference between the structure chart and the execution chart, that the order is important because this is how it gets called. Main calls top hat first calls, top part calls top hat, and then bottom hat. And then once this is finished, the execution passes to the second these are at level 1, goes back to level 1. This is level 2. It comes back to level 1, goes down into level 2, executes bottom hat first and then top hat. And this is how the program works. Now, what we can do is we can even break this up even further. We can break this up and say, the draw 5 lines and draw 9 lines and draw 15 lines can be written methods in themselves, and we can define top hat as draw 15 stars and then draw 9 stars and draw 5 stars and then draw 15 stars. There we go. And then the bottom one is going to be draw 15 stars and draw 9 stars and draw 5 stars. Let's run this program, and then we will see how we can mix and match things just a little more. So this is complete. Let's run it. And we see that we've got our picture back again. But so many changes have been made to our code. Our code now is looking very tidy. We've got the main method called top part, bottom part, and then top part has these two methods that it calls. And then further, top hat calls method 5 stars and so on. So if we go into our PowerPoint slides, we will see that our structure is actually growing, and we've got here top part calls draw 5 stars. I'm going to say then it draw 9 stars, and then it also calls draw 15 stars. And the same for this one. So this is at level 0, this is at level 1, this is at level 2, and this is at level 3. So we've got so many levels. And when we look at the execution chart, we can see that now we have to insert. We have to insert here top hat, which actually at level 3 calls draw 5 stars and so on. And then draw 9 stars and then draw 15 stars, right? So this method calls this method, which calls these 3 methods, which calls, I'm sorry, this thing should come here, top hat should come here, not here. So main program calls top hat, top part calls top hat calls 3 methods. And once it's done drawing the top hat, It goes back to level 2, which is bottom hat, which again is going to go to level 3 and draw 15, 9, and 5. So we have created now a very complex structure and flowchart, but our program is now, it's very clear with the method names what exactly our program is doing. And now we have the flexibility that the methods have been defined once. All these methods have been defined, but these are the method calls, and I can call them multiple times to create more and more complicated pictures. I can do this. So if, for example, if I wanted to have a more complicated picture, then all I need to do is use these units. You see, my picture has now become more complicated, and I can I don't need to write another whole program to do this. I can use my existing parts or units or methods that were already tested and join them in any order. For example, I can do this. I can just do, by just changing the method call, I can change the complete picture and create all kinds of pictures and have the flexibility. Now that I have the units, I can assemble them in any order, or I can use as many units as I like to create more complex diagrams.